Eco Ag. And if you want to share your screen, introduce AEA,
Yeah,
that'd be great.
awesome. I'm not the most tech savvy of all people, so hopefully I can
All of that's like
make a
video
couple
on
clicks.
and like small meeting I have to speak in and like noon till
Yep,
one.
I see your screen.
Okay, awesome. Good. Well, great. It's nice to be here. I always love kind of just telling a little bit about what we're up to and what I do behind the scenes is we get a lot of questions about like who are we and what do we do, and it's really cool to we're kind of very connected in just looking at soil as a whole and a whole system. So I've put together just kind of some key talking points, and at the very end I figured I'd leave a little space for questions for anyone that wants to dive into specifics there. Please, it's always way more fun if it's a conversation, and if you have specific questions, so please don't be shy at the very end there. So my name's Rochelle Moss. I'm a senior agronomist for Advancing Eco Agriculture. I'm in St. Louis, but I really work with crops all across the United States. I used to lead the Southwest region, so worked a lot in orchards and vineyards and things like that, and kind of back home now. Makes a lot more sense for me to be working here in the North Central team and leading that than the Southwest, but sometimes just knowledge and things, we like to kind of share that. So I'll kind of just started here with just topics of why people come to us. So a lot of growers have questions on, and these are all, very common things that come up. There's always like something that needs to be solved. And typically we have a lot of growers that know that our founder of our company, John Kemp, talks a lot about nutrient management and different nutrients that can help solve some of the key issues that we get. So, pests and disease, we are always looking to how to manage nitrogen and the reduction of that, which also kind of comes with goes hand in hand with conserving water, especially in some of the droughtier regions. That's really been key in the last several years. Fruit quality becomes something as we're packing things further or trying to store things longer. That's always something that people come to us with, and obviously yield is always on the front of our minds, and just how we can increase that yield. But really, all of these things have to do with the same thing in a plant, and that's just managing nutrients and keeping our soil and the whole system healthy. So we really rely on what we like to call is like a whole system approach. So we look at the soil and our water source and what is coming from that water source. Sometimes there's really valuable things. We have some areas that actually have a good content of boron in their water source, and that's always nice to know. But we also get these really lovely things, bicarbonates and sodium and all kinds of other fun things that can come with the water. So it's always really great to see the whole picture. Again, nutrient balance is probably going to be the biggest thing that I talk about here. And photosynthesis is something that we kind of just think just naturally happens, but there's things out there that we can really help to maximize photosynthesis. But kind of looking at the whole system approach, we're trying to increase that photosynthesis. But when we do that, it's really cool because if we have enough sugars going into photosynthesis and we're creating that glucose, the excess sugars will actually go out through your root system, and we get accelerated microbial activity. And then we get efficient mineral absorption from what we have there in the soil, and we can mine that efficiently in the plants. And then we're back into this cycle and creating this pest resistance and getting the quality we're looking for, and kind of all the things kind of magically work. This does not happen overnight, but it definitely can we can start to look at things. So I'll kind of look at, this is what we call the plant health pyramid. And when we start talking with a grower, we're looking at the soil and the health of their plants and water source and all of those things. There's a lot of stuff, going on, but we really try to focus on two levels at the very beginning. And that the first level you can see on here is complete photosynthesis. And it goes up. So I'll kind of like go through. So we work with complete photosynthesis and trying to get that to happen first. A lot of that is just with nutrient management. And then we'll look at complete protein synthesis. And that is a lot with the nitrogen and making sure we're utilizing that. But if you get to these third and fourth levels, that's when really a lot of really cool magic and resistance happens because you get this increased lipid synthesis. So when you see like a waxy sheen on a plant, that's what we start seeing in that third level. And then up into the fourth level is when we get a lot of really cool antioxidants and different things in the plants that we're looking for to help our health in turn too. So I'm going to talk about that first level there, which is complete photosynthesis. Most of the time, we're just thinking that this is happening naturally with our sunlight and if we have water, that's awesome, right? But there's also a balance of nutrients that if we're lacking in one of those, we can really kind of hinder the amount of photosynthesis that's happening in the plant. So we're really looking at, if you look at the bottom here, they're listed as magnesium, iron, manganese, nitrogen, and phosphorus. Those are all really essential to those first steps of photosynthesis. And if we have all of those things present, and one thing that I will point out is we'll see when we balance some of these nutrients, one of the limiting factors we see a lot is air exchange. So just something to keep in mind as you're kind of looking at whole system approaches. Sometimes the biggest thing is sometimes the simplest thing when we're trying to fix some things. But it's really cool because even at this first level, we can get resistance to soil-borne fungal pathogens. So I have a lot of guys that come growing melons is like a common one. I was just talking to someone yesterday and they have fusarium issues. And it really can be a first season type thing that we're helping fix some of these fungal pathogens that everyone thinks that you have to fight forever for. So that's really just in that first level. And then we get into that second level is usually what we're trying to help sometimes coincide together in the first season, but a lot of times it kind of works over 2 seasons or so. But complete protein synthesis, when we work with someone on nitrogen, and nitrogen efficiency and cutting back nitrogen. This is also making sure that the nitrogen that we're utilizing is being, I'm so sorry, I think my dog might be trapped in my room. So excuse me 1 second. About that. Oh, she's not the smartest. So complete protein synthesis. A lot of times growers come to us and they're really trying to cut back on nitrogen, or maybe they're trying to cut back on water and utilizing these things a lot more efficiently. So as we're looking at nitrogen, we're looking at different forms of nitrogen and how we're complexing those through the season. So, if we have soluble nitrogen compounds, if we're able to convert those really readily into amino acid and more complex forms, then the plants are able to utilize them a lot easier. This also gives us resistance to insects with really simple digestive systems. So things like whiteflies, thrips, you can see the list there, but there's quite a few that we can really kind of knock out just by managing that. And at this level, it's really looking at also added to that first level of nutrients. We're looking at magnesium, sulfur, molybdenum, and boron to really help that protein synthesis happen. And you may be like, this is a lot of stuff. How do you even know what's going on in the plant? So one of the things that my company is known for, and many of you have probably heard of by now, is plant sap analysis. So we utilize plant sap analysis to go out. Sometimes I'm grabbing those in the field, and sometimes I'm having my growers help me with that. But it's a really, really cool tool to be able to look at the plant and look and see these relationships, and does it have enough magnesium? Am I getting, complete photosynthesis? How do we know that? Like that's where this tool really, really comes into play. So I've kind of cut this off. This is actually maybe about half of the nutrients. So we have 23 different nutrients that we're looking at on this analysis. And as you're looking at this report here, there are some blue bars in the middle, and that's really where the optimums are. So as you're looking at this, you're seeing where's my potassium at right now? So if you look down to the fourth line, the bright green is telling you where the new leaf is, and then the dark green is telling you where the old leaf is. And potassium is really mobile in the plant and in the soil, through the plant. So we can have that in the soil, and we're able to move that through the plant really readily. So we know that we can move that from the old leaf into the new leaf. So if I'm looking at this plant sap analysis, I'm seeing that my old leaf is actually being drawn down and keeping that new leaf at that level. So if I continue to see that old leaf drawing down, we know that our tank is actually getting low. It's kind of like a storage for the plant. There's other nutrients that we look at that do not do that, as you can see on the calcium. The next line there, the calcium is not moving from that old leaf. The darker green line is not going down and filling that newer leaf. That bright green line above it is not taking from that old leaf. It's because it's not mobile in the plant. So as we're looking at a plant sap analysis, I can't use from that old leaf. So I'm always looking at that new leaf to see where I need to move up. So right now it's pretty deficient, and it's not in that optimal range. So it's something that we would be working with. And we would look first on here, as I was talking about, the photosynthetic nutrients are super important. So that's where I would focus, like my very first sap analysis. We would really look at some of those nutrients to help balance those first. And so that's how, you're not trying to balance everything all the time. It's really focusing on two things first. This is really blurry. Sorry, again, my tech skills and my babysitting of dogs is clearly not the best, but so our sap analysis process, I get this question a lot, so I thought might be helpful if some of you haven't done a sap analysis. It's like, well, how does it work? Like, how are you just like, you get these leaves and what happens to them? So we get an order, from a grower, and they get a kit. And what that kit really is some baggies and an instruction guide. And you're really going out, or you have a sap tech. Sometimes we have areas, or myself, that I'm going out and helping growers to actually grab these. But you're grabbing the new leaf from a plant, and putting those all in one baggie. It's just like a Ziploc quart size bag. And then you're putting all your old leaves into another quart size baggie. So they're separated. And then you have labels that go on each of them. So you're just going out into your field, and depending on the crop, the sample collection could be a little bit different. So you can have some that are like, let's say corn is one of my favorites to collect. Why? Because corn leaves get pretty large. So when you're going through the season, and by V4, V5, these leaves are pretty substantial, and we're actually gathering just the inside 4 or 5 inches of that, and then stacking those up and putting them in the baggie and sealing them. Whereas if you have alfalfa or rice, young leaves, you're probably not going to be super happy about collecting those because it takes forever to fill a quart size bag. But I really feel like the data that you get from it. And a question that I get commonly is like, how many do I need to do a season? Because they can be pretty pricey. And I always recommend for, local area like row crops, really it's just one new leaf for a very young plant first in the season, and then 2 sets later on. So it's not really, unless you're using this for a really high value crop, I wouldn't, the cadence of it doesn't really make sense for the data, if that makes sense. So once you've collected those samples, you're shipping them over to the lab, and then the results actually come in pretty readily after they're shipped over into the lab. And then I get an email from my growers' results, and then they get one too, which kind of triggers another automated email. So we actually set up a consultation right after that data comes in, and then just, kind of like as I was looking at the SAP analysis report, I'm looking at that with my grower, and then we talk about what our plan is doing, what do they look like. We're thinking about like, what is the timing right now? So like, is my plant in a vegetative stage, or is it in reproductive stage, right? So the nutrients that we are looking at particular key points is going to change what I'm like focusing on, right? So we have 23 different nutrients that we're looking at on a SAP, but not all of them are important all the time. Or I shouldn't say they're not important. They are important, but there are some that are more important at key particular times. So this is always kind of fun because when we're thinking about vegetative versus reproductive, some of you may know of these nutrients, but I think everyone thinks of nitrogen as being vegetative, right, and making things grow, but you really get a lot of vegetative response from potassium and calcium and chloride, as well as nitrate and nitrogen. And then on the reproductive nutrients, really it's everything else. So if it's not on this, this vegetative side, it's on the reproductive side and helping out some key process in the reproductive side of the plant. But I want to point out one thing on here, because this is something that we focus on too, is you'll see that calcium is on the vegetative side of the nutrients, and calcium can give you a really strong vegetative response in the plant, especially if we get that up early. But it gives you, so I'll use like soybeans as an example. So we can get these really, really large plants, that are long and lanky, and that's usually because we have nitrogen in that system. Or we can have really kind of squattier plants with really short internode spacing, which also gives us a lot more pods, right? Or pod spacing or pod potential. And that's because of a calcium, more of a calcium response vegetatively. So we have a lot of growth, and we have a lot of bushiness, and we have like a good sized plant, but we have that internode spacing down, and that's always because of calcium. I kind of touched on this. I'm not going to go in depth, but so basically anytime we get a SAP back, we're customizing the program, and like the critical points of influence that we have at those particular times. I was trying to think. I know there was something right before my dog was barking, and I was thinking I should have added this, and now it's lost. It's lost in space. But does anybody have any like questions that you'd like to ask? I know I like rattled through pretty quickly.
Hi, Rochelle. My name's Dave Gottenborg. I am a hay farmer, basically, up here in the high country. Just going through your website, it looks like a lot of what you all focus on is, you focus on grains like wheat and corn and so forth, rice and hemp and so forth. But can you discuss maybe how your program might be applicable to different grasses such as hay forage?
Yeah, so glad you asked. And I feel like sometimes our website can be deceiving, because it used to be very like orchard focused. I feel like the pictures were, and then everybody thought, oh, that's all we did was things in orchards. We do things with everything. We have a lot of dairy farmers. We have a lot of just a lot of pastures in general, but for all sorts of reasons. So yeah, this can be such a good question. So when I was like kind of going through the hierarchy of the plants in the plant health pyramid, when we get to that level where we get to that third level where we get more lipid synthesis in the plants, I kind of touched on that, but that's really where we're looking at pastures and putting on weight. So we see once we get to this certain level in our grasses, you're actually gaining more weight than you would on a grain diet at that point. So it's really focusing on, again, just overall nutrient balance and getting to that higher level actually makes the plants more nutrient dense, right? And if you think about a plant actually will store things as a lipid just like we will, or and that makes animals gain weight faster, which is, of course, what we want. Good question.
Thank you.
Yeah, you're welcome.
Does anyone else have questions for Rochelle?
Thanks for asking. I like when people ask questions. It's way more fun.
I was wondering, Rochelle, can you talk a little bit, maybe just very broadly, about like pros and cons of doing a SAP analysis versus like a soil test? Because I know
Yeah,
lots of
question.
farmers usually take a soil test. Like, is it good to do both? And like, how do you
Yeah.
compare
We-
them side by side?
Yeah, I actually like to have both. I would say, they're all resources, right? I like to know what's in my water going on to the plant, and I like to know what is actually available in the soil because that tells us like what do we have to draw from? Because if we don't have, think about Florida, not a lot of minerals in their sand soil down there. So we're really we're looking at adding carbon or a humicarb or something like that in there. And then really having to add amendments, a lot more amendments in an area like that. Then we're looking at maybe in a really rich Illinois region or something, we may not have to add much at all. We really are just focusing on microbial health at that point and unlocking what is in the soil. But we can't unlock what's in the soil if it's not there, right? So that's really what we focus on the soil test. I feel like the biggest two things that we add to a soil as amendments are calcium, because you have to have it in the roots. Like we talked about, it doesn't move through the plant readily. And then boron. Boron is one of those that neonic can do a lot. And speaking of pastures, like alfalfa pastures always benefit from these boron applications really readily. So those are, I'll just maybe add another piece to that is the type of soil test can really help. Because if you get these general soil tests, they're great. They're great to have a benchmark, but I'd almost rather have a deeper dive every 5 years than these kind of traditional ones every year because you get, so like if a Haney with a total digestion, total mineral, every lab calls them a little different, but usually they're called a total mineral digestion. And why that's different is it actually will show you what's available in the soil and then actually what's not available in the soil. So you'll get kind of the traditional results and then the non-traditional results is like, if I could unlock all of the things in the soil with microbes, what would be there? And that is super valuable because then I know, boy, you have tons of calcium in your soil. We're wasting our money putting that amendment out there. We really should focus on microbes. So yeah, good question.
Awesome. Thank you so much.
Thanks.
Does anybody else have questions for Rochelle?
Oh, that's just something else. I was like, I thought somebody put something in the chat.
All right. If there are no other questions, we'll switch over to you, Camille, and hear about EnSoil and your algae product.
Okay, can you guys see the presentation?
Yep, we can see it.
Okay, great. Something just changed on my screen. Okay, great. Thank you so much for having me here, and I'm excited to talk with you all about our work with algae. So my name is Camille Newsom. I'm the Director of Education and Grower Support at EnSoil Corps. We grow a, excuse me, a live cell microalgae product. I was at a conference last week and I've kind of lost my voice, so please forgive the crackle. Um, we grow a live cell microalgae product called EnSoil Algae. So I'm going to start with the sort of history of our company. I also just wanted to mention I'm based out of Michigan. I'm a farmer myself. I farm with livestock. And it's been amazing to work for this company and with our animals to be able to kind of see some of the things that we're looking at here. So our company, Enlightened Soil Corps, is really founded on the mission to empower farmers and land stewards in the effective and profitable implementation of a regenerative agriculture system. We work with a lot of folks that are in a transition state, and we love to call EnSoil Algae a great transition tool. We were founded by a cardiologist who was noticing a nutritional deficit and wanted to look at biological forms of agriculture. And so that's kind of the history of where we started. And now we're moving, forward from there, still focused on nutrition, also focused on profit and whole systems design for growers all around the US and in a couple other countries. So as I said before, it's a live cell freshwater microalgae. The species that we grow is called Chlorella vulgaris. This is found all over the world. It's not anything new. It's just a very high concentration of cells that we're growing. And the reason that this is marketable is because we grow it in a way where it can survive in the dark. So it can be shelf stable for a grower. So we grow it in the US, we're OMRI listed. And I want to start by talking just briefly about sort of what this is. This may be new for a lot of folks. So we see benefits of adding microalgae to a system sort of in 5 major categories. And I'm going to focus a lot on the last one for the purpose of this webinar with nutrient management. But just to sort of briefly talk about overall what this is doing is we see an immediate improvement in biodiversity and the functionality of the soil microbiome. We see an enhancement in chlorophyll and photosynthetic capacity. We see a strong adaptation for stress response, and this could be, a biotic stress like a pathogen pressure. This could be an abiotic stress like drought or heat or salinity in the soil. So there's a response there, and that's really due to the phytohormones that are released from these live algae cells in the system. We see benefits with water management, with retention and infiltration capacities in soil. And then finally, the nutrient benefits, which is what I'm going to sort of focus on for the rest of the time here. But this algae is supporting in making nutrients more bioavailable. It's supporting in the uptake, and it's actually actively participating in the uptake. And then it's supporting in the density of the crop, whether that's the leaf or the fruit or the harvested crop. Okay, so just a little bit of sort of how this works, and then I'll get into some practical case studies and things that we're learning. So in the soil at the root tip, there is a cycle that occurs that's called the rhizophagy cycle. And from a very basic word standpoint, this means rhizo is root and phagy is eating. So it is the process of root tips taking up things from the soil. Most of the time, this is endophytic microbes, endophytic just meaning they can go inside of the plant. So this is really a process where plants are extracting the nutrients from these microbes in the soil throughout their growing cycle. This happens at really young roots, and it happens at root hairs, and it happens throughout the whole plant's life. So the way that the algae is interacting in this system is basically as a carrier. And all of the images you're seeing here are from our work with Dr. James White at Rutgers University. We've done a couple of trials with him in different phases to understand this mechanism. But I'm going to sort of walk through this process quickly, and then we'll move into the data. So when the algae is applied, I'm going to start in the top middle. I don't know if you guys can see my cursor, but when the algae is applied, the plant roots release exudates that attract soil bacteria, and oftentimes are attracting other soil microbiology as well. Those bacteria surround the algae cells, as you can see in the middle photo. And then the bacteria actually enter the algae cells. And so these are what are called endophytic bacteria. The algae are also endophytes. So we use the metaphor of a bus here. The algae acts like the bus. Everybody gets on the bus and it gets filled up. So you can see in this image here, we have those algae cells that are then filled with different soil microbes. Then those algae cells actually enter the plant root hair. So they go inside the plant root hair, and once they're in the plant, there's an oxidation reaction that occurs that allows the algae cell to release what it has inside of it. So when we are talking about this in layman's terms, the algae, the bus sort of opens its doors and things get out. And so that's going to be the microbes, that's going to be nutrients that were carried there, that's going to be the chlorophyll that gets absorbed into the plant root. And on the left here, you can just see an image of nitrogen fixing bacteria that's inside of that algae and then moving into the plant root hair. We do see a lot of root development and root hair development, and then of course that chlorophyll absorption. So this is just sort of a nice image to see that interaction. So some of you may be familiar with seaweed extracts or kelp extracts or commercial broths. There are some other algae products on the market that are not live cells. And so just to sort of show a comparison of the difference here, this is a seed germination trial on the left, and then just looking at the activity at the root. But really what we're doing here is we're providing the factory of phytohormones with this live cell. It's consistently producing phytohormones. Whereas with something like an extract or a broth, it's more of a single dose of phytohormones, which typically requires more frequent application and just a different effect on the system. So I want to move into some studies, and I'm going to start just with a local situation for the area that y'all are in. So this is a farmer we work with really on the Nebraska-Colorado border. And this is sort of a high level. He's been using algae in his system for a couple of years now. And one sort of example, and then I'm going to get more into the nutrient management specifically. So he's been applying the algae on corn. This is as a foliar, V6 to V8. This algae can be applied to the soil and as a foliar. There's not really a restriction there. He's seeing thicker stalks, leaves that are remaining greener. There is a significant drought adaptation here for the drought and heat stress. That is due to the phytohormone release that the algae has. And then he's seeing a yield bump here on the treated acres. So high level, sort of how this is benefiting folks. The next thing, I'm really excited to share this. So this is a study that we just got back. We learned so much from these folks at Total Acres. And we have two growers here, both corn growers, that we're looking specifically at Haney testing, so biological soil testing, PLFA testing, which is looking at microbiology that's in the soil, and then TND testing, which Rochelle just mentioned, the Total Nutrient Digest, looking sort of at long-term fertility in the soil. So I'm going to walk through that as a case study of how algae is supporting nutrient management in a system. So we're going to start in Iowa. And this, just to kind of ground everybody in how the study was set up, this grower had a standard protocol with the normal amount of nitrogen that he applies. So we had a control with his normal program. We had his normal program plus 4 applications of the live algae. And then we had a nitrogen reduction treatment, which is the treatment 2. And this was a 50% reduction with the same amount of algae. So I'm going to show 2 different tables here just to kind of show short-term benefits and long-term benefits. In this table, we are looking at a soil health calculation, which essentially is kind of a composite number that Regen Ag Labs will show to demonstrate what's going on from a soil health component. We see soil organic matter, and then as a snapshot of nutrient cycling, we're going to look at phosphorus. And if anyone's interested in the whole data here, I'm happy to share the report. So just reach out to me. But essentially what's happening here that we can see is we have a strong increase in soil organic matter. We have an increase in the soil health calculation. And then what's happening with phosphorus is that there's an increase in the arbuscular mycorrhizae population when the algae is in the system, a very strong increase, like 30 to 323. So it's a huge amount of mycorrhizae increase. And arbuscular mycorrhizae specifically really are responsible for attaching to roots, and they're key players in moving phosphorus. Phosphorus is a nutrient that does not move easily in a system. And so what we are seeing here is that that is correlated with the amount of available phosphorus in that system. And so we can infer that this is sort of the algae is supporting the development of these fungi, and the fungi are supporting the availability of the phosphorus in the system. So this is coming from both the soil health perspective and also a short-term nutrient cycling, what is available to the plant. From a long-term perspective, and actually, just to go back for a second, so this grower saw a pretty small yield bump in treatment 1 and a pretty small yield decrease in treatment 2. And what I want to point out with this is that when we're looking at yield, when we're looking at the return on investment here, we want to look at the crop, and we also want to look at what is the value of what's in the soil. And this is what is really fascinating to me. So this table here is from the TND. With the biomass is coming from a PLFA test. But what we're seeing here is a crazy increase in the long-term fertility storage. So these are nutrients that have become available and stored. And I like to use the sort of analogy of like your savings account. So if you imagine the soil as a savings account and you're storing up things in the soil that are going to be available for plants, available for the biology, and that could be this season, that could be next season. This is really looking long-term at what is in your system. So across the board here, we're seeing increases in that. And really what stood out in this treatment was that the nitrogen reduction was benefiting the system and functionality. So we're seeing this opportunity for future savings on fertility inputs. And oftentimes when we're harvesting a crop, we think, oh, we're extracting nutrients from the soil, they're going into the crop, we're harvesting the crop, and those are gone. And what's really interesting here is that actually we've replenished the soil nutrients. And we're sort of building up that bank. And then the biomass increase here also offers a opportunity to improve residue breakdown and have kind of a delayed nutrient release, which again is a really drastic effect of adding this stimulating live organism into the system. Okay, so moving over to Ohio, this is a very consistent result here. Same thing with long-term fertility. And what this is again showing is that the nutrient cycling is active and it's being stored in the system. The reason I don't have treatment 1 on here is that the soil type in treatment 1 was like polar opposite of the control in treatment 2. The numbers are very much not comparable. If you would like to see those numbers, I'm happy to send them to you. But for the purpose of this talk, we're looking at storage from, comparing apples to apples. So this again was a 50% nitrogen reduction plus the EnSoil. And across the board, we're seeing an improvement here. So we're replenishing soil nutrients and not extracting them. And then just for the sake of like, why do we care about this? This is an ROI table from this grower. So he did see a yield bump, a small yield bump with the nitrogen reduction. But really what is important here is the amount of money that he saved. So his return on investment on 100 acres, including the cost of the algae, was about over $4,000. And in addition to that, he's getting this sort of not maybe financially analyzable, but really important savings account in his soil of nutrient that in future seasons is definitely going to play into needing less fertility in the future and being able to reduce those input costs. Okay, so moving on to livestock and feed. So this is just a different way of looking at how soil health and nutrient management are related in these systems. So I want to talk about a group of ranchers that we work with in Montana. They're cattle folks. They have been feeding, using the microalgae on their feed, so spraying it on their pastures, hay fields, alfalfa, and either grazing the cows or feeding that to the cows. So some observations that we've seen here are in the measurable cattle health improvements. I'm going to talk about feed values in a second, but the reason that this is affecting cows is that we're seeing things like increased conception rates. And these cattle ranchers are, they have thousands of head of cattle. They're tracking this over a couple of years. 7 to 9% increase in conception rates is a big deal. We're also seeing, and this is maybe even more fascinating, is a lower mineral supplement intake. So the cows are self-selecting to not consume mineral that they have typically been consuming. And this would be supplemental mineral that they're not accessing in their feed. So in this case, this rancher noticed that the cows dropped the minerals from 19 bags to 1 bag over 3 months. And then in the fall, from 9 bags to 1.5 bags every week. And he said, what's going on here? I've had these cows for decades, and this is really different. So we started looking at feed values, and what we noticed in feed values is that the mineral transfer from the soil to the crop was different. The animals were getting a lot more mineral from the feed than they ever had been before, and so their bodies were regulating that and understanding, well, actually they don't need the supplemental mineral as much anymore. And that's been consistent across many growers. So I'll show you some feed values from somebody in Minnesota growing alfalfa for cattle as well. He was looking at protein content, feed value, feed quality, total digestible nutrients, and we're seeing the same thing here. We're seeing this transfer. We've looked at this with micronutrients, we've looked at this with macros, and it's quite consistent. And the reason for this really is, one, the rhizophagy cycle and how the algae is working in that to improve the stimulation of the biology. And also that when the system has improved function, both the soil system and the plant systems, then there's more nutrient movement and there's more uptake and there's more microbes that are being recruited literally to do that uptake, to activate those pathways and to move the nutrient into the plant. Another just sort of, why does this matter on a financial level? So we have a grower in a different person in Montana growing alfalfa, and this was just a very simple, I'm going to use algae and I'm going to use my regular fertilizer, and I'm just going to compare what happened. And I have Casey's feed values if anyone is interested in seeing them, but essentially here we had very similar feed values, and we had an 81 cost per acre difference with using algae and using fertilizer. And so from the standpoint of quality feed for cattle, the feed was the same quality and we can save a lot more money here. Okay, so moving into veg. I want to talk about a trial with peppers. This is just an example of some nutrient pathways that are turned on with something like live microalgae, stimulating the biology in the system. So this is down in Georgia with peppers. And really what we're seeing here is that there are very statistically significant increases in the populations of biology, the populations of microbes in the system that activate key nutrients, things like nitrogen, phosphorus, iron, sulfur, that are also activating the hormonal activity, the heavy metal resistance. And then there's also groups of microbes that are responsible for fighting pathogens, and those pathways were turned on as well. And so this is another example of focusing on soil health, focusing on live biology and improving that. And then these are the things that are coming out of that. We're seeing these other communities of microbes that are activating these roles. They're waking up and they're supporting the system in these ways. So you can see here we have nitrogen release, we have phosphorus assimilation and iron assimilation, sulfur cycling. So there's all of these different mechanisms that are turning on because of this. And so for the grower, what they're experiencing here is a yield increase of about 13%, and then translating that to about 6,000 pounds per acre increase in yield and about $4,000 per acre ROI increase. So just with this small application of tiny microbes into the soil, the results can really be expansive here. I want to add something, and I don't have a slide to show this, but I did send this out in the pre-email. So we worked with a group called Rise Bio. They are a metagenomics lab. They study essentially nutrient movement from soil through the rhizosphere, through the root zone into plant tissue. And there are a couple of really interesting things that we learned there. And so I just want to kind of talk about that for a second, and I can put this up. And I can send out the report afterwards, and if anyone's interested in talking more about it. But the sort of takeaways from this is that we were able to watch in corn, soybeans, and milo, the soil nutrient content from a Haney test to the genomics, the genes that are turned on in the rhizosphere, and then to the nutrient levels in the plant tissue. And what we saw here with an application of algae is that the nutrients were moving from the soil into the plant at various growth stages. But what was really interesting is once the sufficiency levels were reached in the plant, whether for a macronutrient or a micronutrient, then the plant started to store those nutrients back into the soil. And so we start to see, oftentimes we think of nutrient cycling as moving nutrients from the soil into the plant for growth, and that's definitely what we want. But there's also times where those levels can be too high in the plant. And so what we started to see is that those levels were actually dropping with application of algae. And so there was a movement back into the soil to store those nutrients in the soil for, again, that long-term fertility benefit. And I just think that's important to mention here as kind of a relationship between focusing on soil health practices and then also what's actually going on in the plant. And like Rochelle talked about with the SAP analysis, being able to see that growth is really important, and how those sufficiency levels can really support the grower in that. So that is sort of some new stuff we're looking at. And if anyone would like to talk more about that, please reach out to me. I'm an open resource for anyone here. We are going to have the folks from Rise Bio on 2 webinars in March. Those can be found on our website if anyone's interested in attending those. They're free, and those researchers will be going through their work with the genomics. So I would love to take any questions if we have time, Liza, and then that's it for me.
Awesome. Thanks so much, Camille. Yeah, does anybody have questions?
Yes, I have a question for you, Camille. My name is Dave Gottenborg. I'm a grass farmer up here in high country of Colorado. Question is, do all, and I watched your video involving the Montana ranchers and so forth. It was very interesting. Do generally all your applications go through a center pivot?
No, so great question. And this is an opportunity to just talk briefly about application. So these algae cells can be applied. It's a liquid concentrate when the product is purchased, and it can be applied in any irrigation system. So we have people that run it through pivots. We have people who run it through drip. We have people who do drones and sprayers. We do watering cans as a soil drench, greenhouse system, sort of, you name it. Any way that you would apply water to a system, you can put this, and there's no tank mixing restrictions. So what I always recommend to growers when you're starting out with live algae is do exactly what you're already doing and add this in. This has a lot of synchronistic benefits with other products. And we have people who put this in a system with any input you can think of. So in terms of application, it is it's very compatible.
Thank you. I noticed that you said that these are where's the word? These are live algae cells, basically, that you're applying. So are there temperature parameters that you need to be concerned with when you're applying live cells like this?
Yeah, great question. So we recommend that you want to apply after the soil is no longer frozen. Ideally, about 45 degrees Fahrenheit is kind of the low end of when you would want to first apply in the spring. We do have people who will apply this late into the fall, whether that's with a cover crop seed or even a foliar application after planting cover crops. But if the soil's, in the 40 degrees Fahrenheit or less, there will be a little bit of dormancy that occurs with the cells. And then on the high end, we have people who apply this in, Texas summer heat of 120 degrees. That's not ideal, but we do still see significant stress adaptation responses with drought. So these cells are very resilient. The thing that I would recommend more than temperature with application is temperature with storage. So if you are able to store this in a refrigerator or in a room temperature space out of direct heat and sunlight, you're going to get the most benefit from the longevity of the cells.
Thank you. Yeah.
Yeah.
And it looked like on some of your, and I don't want to monopolize your time, but I saw on some of those spreadsheet graphs, maybe it was the one in Iowa and so forth, but it seems like they're applying this along with nitrogen. Sometimes it's 100%, sometimes it's 50%. Is that what is recommended?
So we always recommend to do what you're doing with your current program and add this in and see what you observe. There is an opportunity for nitrogen reduction. A lot of our growers are reducing other inputs by using the algae because they're starting to see that they don't need those other inputs. And actually in those studies, it was very clear that the soil was functioning better with the nitrogen reduction treatment. That being said, we're not going to tell anybody like you need to reduce your nitrogen by this percentage in year one. That is not a game that we want to play. And I don't think that it's appropriate to make those kinds of recommendations. But I have seen and I continue to see a strong opportunity for nitrogen reduction. So that is happening. And I'm happy to share more information about that or connect you with specific growers that have kind of been on that path of reducing nitrogen.
Yeah, thank you. We typically don't use we don't use nitrogen up here. I'm just concerned about water quality issues and runoff and so forth. We've got a big river coming through the property. Fishing is a big component of our the activity going on here and so forth. But I'm interested in soil health and so forth too. So I was just curious about that, how to foster soil health, microbial populations and so forth without the use of nitrogen fertilizers. And we graze cattle on it, and that's kind of the input right now.
Mm-hmm. I would recommend doing a soil test to look at what your available nitrogen is, and then kind of having a recommendation made from there on, do you really need to be adding more, or do you have enough that if you add biology, the biology can help you manage that nitrogen?
Yeah, fair. That's a fair question. I'll stop. Thank you very much for your time.
Yeah, thank you, Dave.
Alrighty, does anybody have any last minute questions for Camille or Rochelle? Okay, if not, I will be sending both of their contact information out in our usual follow-up emails. So you'll know how to get a hold of them if you think of questions later. But thank you so much to the both of you for taking the time to come and speak with us and share all about what you guys do. Really appreciate it.
Thanks for having me.
Thanks so much.
Alrighty, with that, I'm gonna end our info session. Thanks everybody for making the time to join us today. Enjoy the rest of your day. Bye.
Thank you, Liza.
Liza.